What is constructor? Special method which has same name as the class name and which has no return type. When constructor is called? Whenever object is created. How many types of constructors? Two types. What are those? Default constructor means parameter constructor means with arguments. Which constructor implicitly comes? When it will come? If there is no other constructor. Constructors are used to initialize instance variables. Instance variables. Which constructor require default constructor or parameter constructor? To initialize different values, which constructor suitable? Parameter constructor suitable. Okay. Can we write both the constructors in one program? Yes. That concept is called constructor overloading. Now, note down differences between differences between method and constructor. Differences between method and constructor. One side method, one more side constructor. Differences between method and constructor. Now, differences between method and constructor. Note on a group of statements into a single logical unit is called as method. A group of statements into a single logical unit is called as method. A constructor is a special method which has same name as the class name and which has no return type. A group of statements into a single logical unit is called as method. A constructor is a special method which has same name as the class name and which has no return type. Method definition, constructor definition. Next. Method can be called after creating an object only. Method can be called after creating an object only. Method can be called after creating an object only. Constructor is called automatically whenever an object is created. Method can be called after creating an object only. Constructor is called automatically whenever an object is created. Method can be called any number of times. Method can be called any number of times for one object. Constructor is called only one time for one object. Only one time for one object. Method can be called any number of times for one object. Constructor is called only one time for one object. Methods are used to perform the task. Constructors are used to initialize. Constructors are used to initialize instance variables. Differences between method and constructor. Say, constructor is called automatically whenever an object is created. If you create object, then constructor called. In the object creation syntax itself, constructor is there. But method, after creating object only you can call. Even with object also, with object reference also. First object created, then only called. And constructor is called only one time for one object. Method can be called any number of times for one object. So one method, if you write show method, d of demo class reference, d dot show n number of times you can call. So method can be called any number of times for one object. Constructor is called only one time for one object. Method purpose is to write task code. Constructor purpose is to initialize instance variable. Now, in a constructor, if I write a task code, it works, but don't write. In a method, if you write initialization, it is not initialization, assignment. But output same comes, but don't write. So constructor purpose is different, method purpose is different. Constructor meant for initialization, used for initialization. Method meant for task, right? For task. Okay. Like that only use. Okay. Now, constructor and method. Differences between method and constructor. This is a concept of constructor. Up to here, constructor's part is completed. Okay. Say, I given 3 examples. First example I given without constructor. I given instance variables initialization without constructor. First 2 example I given without constructor. Second example I given instance variables initialization with constructor. Instance variables initialization with constructor. Okay. Third one I given instance variables assignment with method. Instance variables assignment with method. You see 3 programs you observe. These 3 programs are given day before yesterday. You see. First program instance variables initialization without constructor. Second program instance variables initialization with constructor. Third program instance variables assignment with method. Now in 3 programs you observe. First program instance variables initialization without constructor I given. without constructor. That is it suitable for more than one object? This program? No, this program is not suitable for more than one object. That program suitable for one object only. Okay. Second program, instance variables initialization with constructor. Is it suitable for one object? Yes. One object also possible. Many objects also possible. Third program, it is assignment. Concept is different. It is not initialization. It is concept is different. Assignment. Now, first program, second program, concept is initialization, but output different. Second program and third program, output same, but concept different. It is initialization, it is assignment. Depends upon our task, we have to select. Suppose initialization required. First one also okay, second one also okay. Suppose in your application only one object is there. First one also works, second one also works. Suppose in your application more than one object is there, then compulsory select second one. Okay. Suppose you want assignment only, use this one, third one. Okay. Initialization different, assignment different. You observe in first program, second program, initial value only 101, 102. Employee number 101, 102. Second program, initial value 0, later 101. So difference is there. Okay. First program, second program, concept same, output different. Second program, third program, output same, concept different. Got it? Now I'll ask some questions, give me answer. You observe here integer x. This is which type of variable? Instance variable. Here demo d equal to new demo. This line is valid or not valid? This line is valid or not valid? Valid. But this is constructor. Which constructor this is? Default constructor. Any default constructor is there in program? No. Will it Java compiler provides? That constructor called. With that constructor only 0 initialized. You will get a 0. System.out.println d.x. You observe demo class loaded, open brace executed, main method called, open brace executed, new dynamic memory allocation operator. It allocates memory to instance variable x. Now constructor constructs the object. Then memory allocated with that constructor 0. Memory 0 assigned, 0 initialized. After that, that object referred by d. With that d, I'm calling x. You will get output 0. You will get output is 0. You observe command prompt. Here compilation execution. So output 0. Okay. Now you are getting 0 output. So compilation execution. Output is 0. Now this program here default value 0 coming. That 0 who will assign is constructor. But where is constructor? Implicitly comes. Now if I write like this, 10 initialized. Okay. You will get a 10. You will get a 10. Now, suppose if I write like this, if I write demo, here if I write x equal to 10. It is also called initialization because this total code at a time executed. It is also, you will get a 10. But problem is here, if more than one object is there, it is not suitable. Problem is here, suppose if more than one object is there, D1, demo D2, D1x, D2.x, if it is there, see, it is not suitable. This is not suitable. In this situation, you have to go for parameter constructor. Now int a, here x equal to a. Now this is which type of variable? This is which type of variable? Method parameter called local variable. Here, how many ways to access instance variable? Is this line is valid? How it is valid? This dot. Here implicitly this dot x. After that a assigned. Now here also x. Then what you have to write here? This dot x equal to x. Okay, this dot x equal to x. Now is this line is valid? Give me answer. No. Why it is not valid? There is no default constructor. There is no default constructor. Will it Java compiler provides? Why it will not provide? Already one parameter constructor is there. It will not provide. Okay. That's what. Suppose. Is it valid now? Now you'll get a different values. See, like this. Different values. So here one more thing, default value. The default value who will assign is initialization. The default value who will initialize is constructor. Default constructor will initialize. First of all, this is also written. Every variable one default value is there. Primitive data type, default value. Primitive data type and default value. How many primitive data types are there? 8. What are those? Byte. Second one, short. Third one, int. Fourth one, long. Fifth one, float. Double. Next, char. Next, boolean. Okay. Here, char, boolean. 8 primitive data types are there. Here, byte default value 0. Short default value 0. Int default value 0. Long default value 0. Float default value 0.0f. Double default value 0.0. Char default value blank space. Here ASCII value 0. Here boolean false. False means 0, true means 1. Like that it will understand. That's what false. That means all are zeros only. Write this one. So all values are zeros only. Byte default value 0, short 0, 0, 0. It is 0.0. Here L not required. If out of integer range is there, L required. But here 0.0 also F required. Okay. If the number is out of integer range and within long range, then L required. But it is within integer range, L not required. But this is every float literal must be suffixed with small f or capital F. See, 65 ASCII code. What is that? Capital A. 97 small a. 48 0. Like this, here 0 means something will be there, no? That is blank space. That is blank space. So 48 means 0, but here 48 is a ASCII. That character is 0, but 0 is a ASCII. That value blank space. Here, that's what you are getting, blank space. So here, true means 1, false means 0. Like that, it will understand. That is the reason false. That means at last all are zeros only. All are zeros only. From year to year, all are zeros only. Is it over? So here y blank space is ASCII value is 0. 0 means blank space. That is the reason you are getting 0. Blank space. Is it over? See, I'll write some examples. I'll write, just you see. First writing is over up to here. Now, suppose here int x, float y, okay, char z. Now boolean b I written. These all are which type of variables? Instance variables. Demo d equal to new demo. Say system dot out dot println x, d dot x. System dot out dot println d dot y. System dot out dot println d dot z. System dot out dot println d dot p. Okay. Here d dot x, it is 0. 0 comes. D dot y, 0.0 f in the programming, but output 0.0 only comes. While writing yourself 0.0 f, okay, but output 0.0 comes. Here one blank space. Here false. File, save. You observe. Compilation, execution. See, it is 0. Here 0.0. One blank space is there. After that false. So it is character. Here, suppose here myself, I'll write 65. Then what is output comes? Capital A. Compilation, capital A. Okay. If I write 97, small a. Small a. Suppose if we write 48, 0. See, 0. Suppose year 0 if I write blank space. So on blank space, empty. That is we are getting by default. Got it? So year also 0, year also 0, year also 0, year also 0. But 0 character format, blank space. 0 Boolean format, false. That means all are zeros only. Okay. That's what. Now you are getting output like this. It is 0, 0.0, blank space, false. Compilation, execution. Okay. Write this one. 0, 0.0, blank space, false. That is output. These values are initialized by constructor. That default values are initialized by constructor, default constructor. That's what default constructor also will call. You write this one, node default values are initialized by default constructor. Default values are initialized by default constructor. Default values are initialized by default constructor. Is it over? So in this program, default constructor not there, but Java compiler provides that constructor will initialize. The default values are initialized by default constructor. But if you write your code executed, okay. Now what I'll do, say here I'll write integer x. Which variable? How many ways to access? One way, that is directly. Now your program will not compile. Error comes. See, variable x might not have been initialized. Local variables are not initialized. We have to initialize. Now, if you write like this, you'll get a 10. Even if you write like this also, it is called initialization. But it appears like an assignment. This is appears like a declaration. This is appears like an assignment. But in this case, it is called initialization only in Java. Appears like a 2 lines, but it is initialization. Now, here, this is error. This is error because local variables must be initialized. Because, say, variable x might not have been initialized. You are getting error. Just write it. This one, I'll give notes. Error because local variable must be initialized. Before access. Error because local variable must be initialized before access. So without accessing, without initializing, if you try to access, you'll get error. If it is local variable. Instance variable initialized, class variable initialized, but local variable not initialized. That is you have to initialize. So in this line, no error. In this line, error. Without initialization, you cannot access if it is local variable. Is it over? You studied variables, instance variables, class variables, local variable. You studied methods, 4 categories of methods, as well as instance methods, class methods. You studied constructors, like default constructor, parameter constructor. These all you studied. Now, next concept, blocks. Next node, blocks. Node, node, Larissa. Now write it. Node, blocks. Or just block, write it. A group of statements between open brace and close brace is called as block. A group of statements between open brace and close brace is called as block. A group of statements between open brace and close brace is called as block. Say statements if you group together between braces, between flower bases, then it is called as block. Next, write it. A block is also called as an initialization block. A block is also called as an initialization block because block also can be used to initialize instance variables. A block is also called as an initialization block because block also can be used to initialize instance variables. A class can have any number of blocks. A class can have any number of blocks, and all those blocks are executed from top to bottom order whenever an object is created. A class can have any number of blocks, and all those blocks are executed from top to bottom order whenever an object is created. Blocks are executed before constructor only. 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 See, these all points I have to explain, and after that, what is the use of blocks also I have to explain. Is it over? See, first a block. A group of statements between open brace and close brace. A group of statements here are given. A group of statements between open brace and close brace is called as block. So open brace, close brace, that's it. In between, if you write some code, that is nothing but block. That block we can also call initialization block, because block also can be used to initialize instance variable, because it is also executed whenever object is created. Okay. A class can have any number of blocks, and all those blocks are executed from top to bottom order whenever an object is created. Blocks are executed before constructor only. See, you observe here integer x equal to 10. If I write, when this line is executed, whenever object is created. Okay. If I write like this, what is this? Default constructor. When this is executed, whenever object is created. Even if you write like this also, it is also executed whenever object is created. See, just open brace, close brace. In between, you can write any statement. So system.out.println, something block 1. Now, open brace, close brace. It is called block. This type of blocks, any number of you can write. Suppose here also I'm writing system.out.println block 2. Okay. Here block 1, here block 2. Suppose here I'll create object demo d equal to new demo. Whenever object is created, blocks are executed, but in which order? Top to bottom. So first this is executed, next this is executed. Okay. Now, if you write like this, also executed, because this is also object. This type of object is called anonymous object. We can also call unreferenced object. See, demo class loaded, open brace executed, main method called, object created. Then blocks are executed, block 1, block 2. You observe compilation, execution. Block 1, block 2. Suppose I'll write one constructor also. I'll write constructor. System.out.println constructor. Now what is the output comes? Block 1, block 2, constructor. Okay. Like I given here that point. Blocks are executed before constructor only. Okay. Now here this code executed whenever object is created. This code executed whenever object is created. This is also executed whenever object is created. Even if I write integer x equal to 10, this is executed whenever object is created. This is executed whenever object is created. That's what it is called initialization. That's what this is called initialization block. Okay. Now, like this, output block 1, block 2, constructor, it comes. But what is the use of block? I'll explain. You write this program. Just switch on this light. This one, this one. Is it over? What will be the output? Block 1, block 2, constructor. Block 1, block 2, constructor. See, demo class loaded, main method called object created. Whenever object is created, memory allocated to instance variables, blocks executed, constructor executed. These all executed. But first instance variable memory allocated, next blocks executed, next constructor executed. So blocks also n number of you can write top to bottom order, and after that constructor executed. Now, what is the purpose of constructor? To initialize instance variables. When constructor is executed, whenever object is created. Now, whenever object is created, then constructor is executed. Whenever object is created, block is executed. Same time executed, no? Then here, block also executed whenever object is created. Constructor also executed whenever object is created. Whatever you are writing in the block, that is you can write in the constructor, no? Possible, no? That's what blocks are not in use. Okay. It is only first program. It is only last program. Further not required. Okay. These programs are further block is not required. Reason, constructor is executed whenever object is created. Block is executed whenever object is created. But why this program also? If I don't give this program in a written test, if any question this type comes, then what student will think? Before this brace, something is missed, they'll think. That is also one concept in Java. Okay. Like in a written test, what they'll think is if it is like this, if they ask any question in written test, seeing this line, they'll think something is missed here, either constructor or method required, like that they'll think. That is the reason on program I given. So this is also one concept is there, but not in use. Not in use. Okay. Blocks are not in use. Further blocks not required, but static blocks required. Static blocks required. Now it is a block. It is executed whenever object is created. Constructor is executed whenever object is created. That's what, instead of writing code in the block, write in the constructor. Okay. Next, static blocks. Static blocks. Next heading, static blocks. Note down. A block with static keyword is called as static block. A block with static keyword is called as static block. It is also called as static initialization block. Because static block can be used to initialize because static block can also be used to initialize static variables, nothing but class variables. It is also called as static initialization block because static block can also be used to initialize static variables. A class can have any number of blocks, any number of static blocks, and all those static blocks are executed from top to bottom order whenever class is loaded. A class can have any number of static blocks, and all those static blocks are executed from top to bottom order whenever class is loaded. Static blocks are executed before main method only. Static blocks are executed before main method only. So before block, just if you write static keyword, that is called static block. Instance variable initialized with constructor. Static blocks, static variable initialized with static block. Static blocks are executed before main method only. Here also any number of static blocks you can write. Any number of a class can have any number of static blocks, and all those static blocks are executed from top to bottom order whenever class is loaded. Already given execution priority somewhere while teaching variables. What is the execution priority? Class variables, static blocks, main method. That's what first class variable executed, next static block executed, next main method executed. Now, before main method only static blocks are executed. Okay. Then what is the use of static block? I'll explain. Say, present, we are writing main method. And further, main method will not be there. In that situation, we use static block. I'll explain what is the purpose. First, see the program. First, is it over? So, a block with static keyword is called as static block. Just here static keyword if you write. Actually, it is called block. Just static keyword if you attach, it is static block. Okay. It is also called as static initialization block because here static integer x, this x equal to 10, you can write. It is initialization block. You can call it as initialization because both are executed whenever class is loaded. You can write n number of static blocks, top to bottom order, whenever class is loaded. Here one more static also you can write. Now, this is static block. This is static block. You can write. Okay, any number of. Now here, suppose output just static block 1. Here output static block 2. Now, for calling these, objects are not required. No object. Static means it doesn't require object. Suppose system.out.println main method. If I run this program, what will be the output comes? Static block 1, static block 2, main method. Okay. Whenever class is loaded, first static variables. We don't have static variable. Next static blocks. This one executed, this one executed. Next main method. Okay. Compilation, execution. See, static block 1, static block 2, main method. Write this one. What is the purpose? I'll explain. Output static block 1, static block 2, main method. Okay. First class variable memory allocated. We don't have class variables. Next static blocks. Last main method. See, further what will happen? Main method will not be there while developing internet applications. If the program is running under operating system, then main method required. The program is running under operating system, then main method required. Okay. And further, programs will run in servers and browsers. Internet application will run in server environment, browser environment. At that time, browser doesn't know main method, server doesn't know main method. At that time, we have separate methods, life cycle methods. In that situation, while loading a class only, library required. That is, you can write inside the static block. While loading only, first library loaded. So, in real-time applications, to load the libraries, we use static block. But we can use main method now. While loading only, main method executed. While loading class only, main method executed. At the time only can load with main method. Present okay, but further main method will not be there. In that situation, we'll go for static block. That note down. Static blocks are used. Static blocks are used in real-time applications to load libraries. Static blocks are used in real-time applications to load libraries. Static blocks are used in real-time applications to load libraries. Before starting your application execution only, some libraries required to load. In that situation, we use static blocks. Now present, instead of static block, main method is there, but further main method will not be there. In that situation, we'll prefer static block. Okay. Constructor block at a time executed. That is the reason instead of block, constructor. Main method static block at a time executed. Instead of static block, main method. Present okay, but further main method will not be there. In that situation, we use this. Okay. Now I'll ask some questions, give me answer. Now, class. What is class? Collection of variables and methods. Collection of variables and methods. Okay. Will it class occupy memory? No. This class we are writing in a one file. That file will occupy? Yes. Class will not occupy. File will occupy. Okay. Now, suppose 100 students are there, 5 employees are there. This data I want to maintain in a system through Java programming. Then how many classes we have to write? 2 classes we have to write. Okay. Now, writing main method in employee class better or student class better or other class better? Other class better. So like that, further while developing application, we'll make it separate main method. Okay. Now, here integer x. This is which type of variable? Instance variable. When memory allocated? Whenever object is created. Which memory block it is stored? Heap area. If I create 100 objects, how many copies created? 100 copies created. Okay. How many ways to access? 2 ways. What are those? When we have to use object, if it is required, 1 time. When we have to use object reference, more than 1 time. More than 1 time object reference. Now, when we have to use instance variable in Java programming, if different values are there. If different values are there, we have to use. Now, Here, static integer y. Static integer y. This is which type of variable? Class variable. When memory allocated? Whenever class is loaded. Which memory block it is stored? Method area. If I create 100 objects, how many copies created? 1 copy created. How many ways to access this? 4 ways. What are those? Directly, class name, object, object reference. How many ways are not recommended? 2 ways. What are those? When we have to use directly, same class. When we have to use class name, if it is present in another class. Okay. When we have to select class variable in Java programming, if the same value for all objects, we have to select class variable. Okay. Now, void show like this. Is it instance method or class method? Is it instance method or class method? Instance method. Instance method also we are writing in a class. Class method also we are writing in a class. Okay. Is it instance method or class method? Instance method. See, it is instance variable, it is class variable. For this object compulsory or not? That's what it is called, instance variable. For this object is required. With class name also you can access, no? That's what it is called, class variable. For this one, instance compulsory. For this one, instance is not required. Here also instance compulsory. That's what instance method. But both we are writing in a class only. Okay. It is instance method. Now, instance method, and if you write static keyword, it is called class method. Now, it is called class method. When we have to use instance method, when we have to use class method. If instance variable is there, instance method. Otherwise, class method. In your program, instance variable is there. Then you have to write instance method. Instance variable is not there. You have to write class method. Okay. Now, what is this? Constructor. What is constructor? Class name, method name, same. And no return type. It is default constructor, parameter constructor. Default constructor. Now, it is parametered constructor. Can I write more than one parameter? Yes. Can I write both the constructors in a one class? Yes. This concept is called constructor overloading. Constructor overloading. Okay. What is this? Block. What is this? Static block. So, in a class, we can write instance variable, class variable, instance method, class method, default constructor, parameter constructor, block, static block. This is all you studied. Okay. With this knowledge, you can understand principles, object-oriented principles. Okay. But before going to principles, first I'll complete arrays and strings reference data types also. With that, you can develop some applications. With that, you can practice assignments. Okay. Assignments purpose first I'll teach that one. Now, assignment one, assignment I given, how many people completed? At least 3 programs. How many people completed? Just raise your hand. 3 programs at least. Okay. So tomorrow I'll discuss about assignment. At least today, try to complete. If you don't get, I'll teach, but you have to try first of all. Whether you are getting or not, leave it. First you try. If you are not trying means you will not get a subject also. But you tried, but you didn't get, I'll teach. No need to worry. But you have to try. You'll get a skills. But everything, if you depend on me, you'll not get a subject. You have to practice. My role is 30%. Your role is 70%. That always remember. Okay. Myself, I'm teaching to all same, but all are not getting subject. Reason depends on your hard work. Okay. Now that's what, at least today you try to complete. Tomorrow I'll discuss about assignment. You studied already data types. How many categories? 2 categories. What are those? Primitive data types, reference data types. How many primitive types? What are those? What are reference data types? Arrays, strings, classes, interfaces, dash dash, etc. Many we can create. Records, sealed classes. So many are there. Enumerations. Okay. Now, next we'll see arrays. Node. Next concept, arrays. Node. An array is a collection of similar data elements. An array is a collection of similar data elements. An array is a collection of similar data elements. If same type of elements are there, that is called array. Otherwise, you can write one more definition, homogeneous elements. An array is a collection of homogeneous elements, nothing but same type of elements. An array is a collection of homogeneous elements. It is also right. An array is a collection of similar data elements, same type of elements, that is homogeneous elements also will call. I'll explain. Array index always begins with 0 and ends with size -1. Array index always begins with 0 and ends with size -1. An array index always begins with 0 and ends with size -1. In Java, array itself an object. In Java, array itself an object. So same type of elements, if it is grouped together as a one collection, that is called array. Same type means we can call it as technical word homogeneous. Homogeneous also we can call. Index always begins with 0, ends with size -1. I'll explain with the diagrams examples. In Java, array itself an object. Array reference is also called as an object reference or reference variable. Array reference is also called as an object reference or reference variable. Array reference is also called as an object reference or reference variable. Array reference is also called as an object reference or reference variable. Now, say whenever array is called object, array reference is called object reference. But object reference we are calling like a reference variable we already studied. Okay. Next, declaration syntax I'll give. Array declaration and creation. Declaration and creation. Syntax. array declaration and creation syntax. Array declaration and creation syntax. Here, data type, array reference, array operator equal to new data type size. Data type, array reference, array operator equal to new data type size. Example. Data type, suppose integer, array reference A, array operator equal to new integer, suppose 5. This one you can also write like this. Int